case, I would be dividing this like this. I'd have to maybe add a line. So I think that's pretty much showing the way it works. Now, once you've done an entire sheet and divided things up like this, the next thing that we really want students to do is we want them to start to memorize. The formula for volume, and to practice writing it down. So volume equals, and it really is volume equals base times height, but base is length times width usually. So you can also write it as length times width times height. Students often think they don't need to do this, but keeping track of this formula and inserting the numbers in it really helps you solve it. So asking students before they ever do any work with the numbers just to list the formula like that, that's really going to help them. And I like to use the length, width, and height because it really helps them know you've got three things on here to multiply. So which one do you call length, width, and height? It doesn't really matter. Since this one is easier in this graphic to solve, they're all labeled, I'm going to start with this one. I'm going to rewrite the V. Length, well, I'm going to go ahead and call that 12. And I just tell the students which number kind of pops out to you first that you can clearly see that's one of the dimensions you're going to use. Well, 12 is really big and obvious there. 3 and 2 are also pretty obvious, so 3 and 2. And then they can multiply that. And it does not matter the order in which they multiply that. For example, your student may see, they may want to go 12 times 3, that's 36, times 2, that's 72. Or you might have a student that says, well, I can multiply the 3 times 2 and that's 6, and 6 times 12 is 72. It doesn't matter how you multiply those because they're all going to come out the same way. 12 times 2 is 24, times 3 is 72. The order doesn't matter, and neither do the names of what you call the different sides. So on the top here, this is the one that's a little more tricky, and again, there are lots of strategies you can use to help students see these sort of hidden sides. I know that my thickness is 2, and that's where this model really comes in handy. If the students trace their finger and they say this side's 2, this side's 2, the side in there is 2, this is 2, this is 2 over here, and this back side down here is 2. And they can really see when they hold on to the model that has to be true. It couldn't work as a Lego brick if the sides were not, the parallel sides weren't the same thickness like that. So when you go here, this is 2, 2, 2, 2, this top is a 2 up there. So you know that one, you can label it down, and since that's the first one you found, just put it first. Call it length. Even if it doesn't make sense because it's the shortest, still call it length. Just put it in there. Width. Well, you might say, well, this one right here is trying to figure out how tall that is. And I don't know because it's not labeled. Well, over here on the side, you get a colored pencil and say, this is 10, right? And this is 3. So if 3 and some number would be combined to make 10. So 3 plus, and it has to be 7 right there. And so students should put in the 7. Using colors can help to figure out these unknown lengths. This bottom down here, if I change to a different color, this bottom down here, this entire thing is 12. And this piece of it right up here is 8. And so if this piece here is 8, 8 plus what number equal 12? Well, it has to be the 4. And so that's, if it's 4 across here, it's 4 to this point, and it's 4 up there, and that's your other dimension. So you have the 4. And that it's also is just another really good thing to do with students. I've shown almost the entire problem, and of course they're going to multiply these and they're going to write that amount in there. I like to have students circle it just so that they're identifying this is the volume inside of that space, and when they solve this, to circle it and put it in that space. And then of course they take these final two ones and they're going to add them up, and they become the total volume down here. And in this case you've got millimeters. So we need to teach students that it's millimeters cubed, and it's cubed because we have 1, 2, 3 dimensions at the corner, and it's cubed because in a sense, if this were a cube and it's not, it's kind of a flattened cube. That would be like 4 cubic units, right? Even though they're kind of tall cubic units. Anyway, they're not cubic units like say this would be a great model of kind of what cubic units would be because they look like perfect cubes. Anyway, I really like to emphasize that students' work should look like that, should look nice and neat. That if they solve any extra work on the sides, like they have 14 times 4 that they use here. There's the 2 times 7, it's 14 and 4. They can just be neat and small over on this side like this and show their work. And then that is a really important part of getting a problem like this right, is being neat and not just having like a swirl of bees of numbers around this, but everything's got its place. So Hope this video helped.